But tonight we have a speaker who's from the ICR that has always been one of the leading research organizations. They have a wonderful staff of researchers, but we've got the best one tonight, Dr. Tim Clarey, and he is doing cutting-edge research in geology that will, I think, eventually generate a paradigm shift. And it will demand the scientists' attention, the conventional view. So, Dr. Clarey, come tell us about it.
I got a mic. I should be good. I don't know if I'm the best. I put myself at the bottom. I'm the newest scientist, pretty much, at ICR. I've only been there, well, not quite 6 years. And so I used to work in oil and gas. I don't know if there's any of my old colleagues here or not. A lot of them went down to Houston with Chevron. I worked for Chevron for about 9 years. Bounced around between Denver, Oklahoma City, and then New Orleans, and then they laid us all off in '92 because oil prices were so low. So I'm back for my PhD, but never knew why I was really laid off, but I realize now that was God's plan for me to get a PhD, and then ultimately that allowed me to come to ICR. But that oil and gas training has really allowed me to do the research I'm doing. If I didn't know about oil wells and seismic data, I wouldn't know what I was doing. And many academics, unfortunately, never had that training in oil and gas, and they really don't know what they're doing with oil wells. So they try to ignore them. But the oil wells are really telling the tale, or the rocks that are really there. So this first talk I'm going to give tonight is the truth of the flood based on the rocks that are in place. And you'll see the results of 3 continents that I've studied now. Compiled the data up from 3 different continents, North America, South America, Africa. I'll deal mostly with North America tonight. But I'll add a little of those other continents in later, and I'm actually almost done with Europe. And amazingly, they all show the same story. They show the same patterns, just what you'd expect in a global flood. That's exactly what we see. The rocks tell the tale. They really do show the flood. That's what I want to talk about tonight. My second talk tonight will be on dinosaurs. I know some of you kids are disappointed, but there's a lot of dinosaur books you can buy. But we're going to talk on dinosaurs a little bit later. But these are extended talks, a little longer than my normal talk, because you guys want to hear a little more about oil and gas, so I'm throwing a little oil and gas at the end of this talk as it goes along. So I hope you don't mind. A little oil and gas. Anybody working oil and gas? Oil and gas, when you're pumping gas in your car, that's evidence of young earth creationism right there. And we'll talk about that later. Anyway, was the flood real? A lot of people deny there was a flood. They think it was just a local flood. They try to make it small, just the Black Sea or just the Middle East. The Bible tells us about a global flood. And so the global flood would have affected every continent at the same time, and that's what we're seeing in the rocks. Unfortunately, because of science, secular science has created an alternative story to the Bible, and they say this is scientific, you got to believe it. It's almost become a religion, but unfortunately many evangelical leaders have bought into that. Their seminaries bought into it, and so many pastors and church leaders talk about a local flood as well, not a global flood. But the Bible teaches clearly it's a global flood. You know, my question to people that believe in a local flood is, why would God bring birds on the ark if it was a local flood? The birds could have just flown away. Noah could have traveled. But God talks about a global flood. Even the New Testament talks about it. And evolutionists, of course, try to intimidate many of us Christians into believing this shows evidence of fossils, fossil evolution. But in reality, it just shows things showing up in fully formed fashion, and then they stay the same and they disappear. So all the fossils throughout the whole fossil record show sudden appearance, stasis, they stay the same and then they disappear. And to me, that is explained best by the flood, as we'll see in this talk. So don't let the fossil record convince you that evolution is true, because it doesn't really support it. And they often forget over here on the sides, I don't know if these show up or not. Does it show up on here? Yeah, over here, there's all these marine fossils mixed in throughout. They often just show the first half. But there's marine fossils mixed throughout. There's 6 species of sharks found in the same rocks they find the Tyrannosaurus rex in the Hell Creek Formation. We'll talk about some of that tonight. So there's lots of mixing going on that just isn't really mentioned. It's in the literature, it's in the papers I look at in Europe, it's in the papers I look at across Africa, it's in South America, but it's not brought up. 2 Peter 3:5-6 says, there shall come in the last days scoffers, walking after their own lusts. And sometimes they're not even quite fully scoffers, just doubters. In the last days there'll be scoffers and doubters walking after their own lusts. For this they are willingly ignorant, that by the word of God the heavens are of old, the earth standing out of water. And it goes on to say, whereby the world that then was, the world, not just the Middle East, the world that then was, being overflowed with water, perished. So here we have the New Testament talking about a global flood. Peter wrote down these words that God told him to write. And he said, this is a global flood. And people are going to deny in the last days there was a global flood, and that's exactly what we see. Rampant denial of a global flood. Evolutionists deny the truth of God's word. But God's word, he says in Psalm 119, thy word is true from the beginning. So the word of God is true throughout. It doesn't start in the book of Joshua. It doesn't start in the book of Ruth. It doesn't start in Matthew. It starts at the very beginning in Genesis 1:1. God's word is true throughout. And so every word of that Bible is inspired. Every word of that Bible is true. So we're going to look at tonight in an extended version of my talk, and you can get a shorter version of this later if you want to buy the DVD. Short version, 3 truths of the flood. The first is that it was a global flood. And I'll spend most of my time convincing you that that's what the rocks show. They really do show evidence of a global flood. Secondly, it was a catastrophic flood. It wasn't a flood that just sort of filled up like your bathtub. It was very, very violent. Waves, tsunami waves bigger than we can imagine were probably taking place. And as the water got higher and higher, those tsunami waves got higher and higher. Washed away and wrapped up huge dinosaurs. T-Rex Sioux was found basically with its snout in its pelvis. It was wound up in a ball because there was such violent waves going on. Many of the dinosaurs are ripped apart. And that's why very rarely do we find complete dinosaurs. And then I'll talk about, it was a recent flood. This is the biggest problem for many Christians. They can't quite get their head around that the flood really did happen probably about 4,500 years ago. 4,500, 4,600 years ago. Not that long ago. And the evidence is there to support that as well, and I'll show that as we go through this. But the secular world believes there were 6 floods. They believe there were 6 global floods, or mega sequences, or sloths called them sequences, but now the names have gotten so out of hand, we have to go with something big like mega sequences. So we're going to 6 mega sequences or floods. This is the first one, the second one, the third one, the fourth one, the 5th one, and then finally the 6th flooding. And none of these, of course, they show it flooding the entire world. This is just North America. But there's evidence that these floods have ultimately went over the top, and we'll see as that goes. It didn't start out that way initially, but it did. And so this is the secular chart, kind of sea level curves that go on. There's the names you're more familiar with, Cambrian, Ordovician, et cetera, but we're going to use these names on the end. And so we're going to have a quiz later. See if you guys can get out of here and spell them correctly and get them in order. But the Sauk sequence, named after sloths, named all these after Native American tribes. The Sauk includes the Cambrian plus a little bit of the Ordovician. Tippecanoe, the Ordovician, and Silurian, et cetera. So he used these because these are big events where the floods covered the continents, or major portions of the continents each time. So they kind of came in and went back. Now, they believe this took millions of years in between. But we'll see the rocks don't show millions of years. The rocks show bricks, just like bricks in a wall, stacked on top of each other for the most part. We're going to use these names, though, 1 through 6. We're going to look at these as chapters of the flood. And so there's really actually almost a chapter thing of the flood going on as you go through these things. Now, there's a new article I wrote in February's issue, Facts and Facts, which you can sign up for and get for free. It's a new article where I show my version of what I think the flood really did. And I read a secular article about this. They admit that's what they see, that the sediments are very minimal early on in the Sauk, and they get more and more and more up to a point. And so I have a new sea level curve that I published in the February issue, if you get Facts and Facts, or you can get this. There's free ones out there on this that shows this. But I don't believe this sea level curve is accurate anymore. I think it shows one progressive flooding, and then it goes down, just like the Bible describes. There's even a pre-Sauk. And what I did in my studies, I tried to use as much data as possible. Science should be data-driven. I had no idea where this would go. I believed in a global flood, because the Bible talks about it. But I said, let's see what the data shows. So I started plotting up oil well data and columns, stratigraphic columns all over the United States. Then I went into Canada, went into Mexico, and finished up North America. Found out what I could around Greenland. There's a lot of evidence around the outsides of these. And then I went down to South America and Africa. Started looking at these things, and I started seeing patterns. Every continent started showing the same thing. But this is observable data. it's about 85% repeatable. The other 15% is where I have to kind of guesstimate, because not every well goes down deep enough. Sometimes it just kind of stops, and there's seismic evidence there's more sediment, but we don't know what's down there. And so sometimes I have to kind of make a reasonable guess. But 85% of what I'm doing, I think, is repeatable empirical data. And you could do this yourself if you want to spend 5 years of your life. And I'm hoping to maybe get done in the next 5 years as we go along. But it is, and we've got over 1,800 columns. I think we're over 2,000 now, counting Europe. And so this is an example from the Michigan Basin, my home state. That's why I have this accent. Some of you think I have an accent. Who thinks I have an accent? Okay, man. Really? That many? Okay. Well, it's a Michigan accent. And I lived in New Orleans. Didn't that help? Laissez le bon temps rouler. And okay, that didn't help. Oklahoma, I lived there. I lived in Dallas now for the last 6 years. That didn't help either. I can say y'all. Y'all come back and... Okay. Anyway, this is the lithology right here that shows all these. These are a well, and the sequences are shown here on this side, and this is the different rock types. So I keep track of 16 different rock types. Cherty, limestone, carbonate, whatever you call it, salt, gypsum, all the different things, sand, shale. The blues are generally the limestones. The sands are generally yellow. Shales are generally brown, and we'll see that pattern throughout. Then the mega sequences as well. So I keep track, and this is in meters. It's 5,000 meters. So we keep track of the depth. So it goes into a database. And so we're going to go through the history of what I see of the flood, how it progressed across North America, and then I'll add in the other ones as we go along. So the very beginning, if you go back to the Bible, it talks about the flood started out with the fountains of the great deep bursting on day one. So it says in Genesis 7, in the 600th year of Noah's life, were all the fountains of the great deep broken open, and the windows of heaven were opened. Exactly what that means, I think this might have been where the plate boundaries actually originated. There's a big debate in geology. Where did the plates come from? When did plate tectonics activity begin? Well, I think it began here. There's no other planet in our solar system that has a plate, has plate tectonics, just Earth. I think they began right here at the flood, and you had this massive amounts of lava and water pouring out from deep, possibly underneath, might have originated below the crust even. So I don't know if there's really water down there, but there's water stuck in the rocks. And we see now there's more water in the upper mantle than there is even in the oceans, but it's not sloshing around. It's within the rocks and within the minerals. But those mags reach the surface, it releases that water. And so a lot of water might have shot out as geysers almost. So we have the fountains of the deep bursting all over the earth simultaneously all at once. Fountains, I think these were the plate boundaries. And you can see the plate boundaries still today. In the scars kind of in the ocean, you can see the mid-ocean ridge down the Atlantic, kind of right through here, this big ridge system is 10,000 feet high or so. And then you get the East Pacific rise that gets tucked into North America. You get the Indian. Every ocean has a ridge because the ocean crust was generated at those ridges. During the flood, the old ocean was destroyed. The new crust was created very, very rapidly. And John Baumgartner's done a lot of work on that. So this is the mapping of some of the pre-flood, pre-sock, I guess we want to call it, sequences. Very thick amounts in the east. The mid-continental rift actually has places where the lava is 10, 12 miles thick, where it poured out an area the size of the Red Sea. Then you get this was the West Coast originally at one point. There was no California. That was all added on during the flood. So California's geology was kind of a collection of all this debris that was in the bottom of the original ocean and got smeared onto the West Coast. And so most of you that study plate tectonics understand that. And we believe that actually happened very rapidly during the flood. So the geology of California is really screwed up. And I think you become like the geology you live in. It explains a lot, doesn't it? Every sliver is different. Every 50 miles is something different. And now that's not true if you're from California originally. I'm sorry. But see, notice Texas is very stable in the middle of the country, and even my home state of Michigan, we're a little screwed up. A lot of activity going on. But the East Coast is a little screwed up. The West Coast and in the middle of the country. Fortunately, there's Texas. And so I got here as quick as I could, as they say. So. But if you go to Canada, because I can speak Canadian, you can see all these lava flows up here, these big black lavas that poured out as part of that mid-continental rift. That pink rock is granite, but these lavas poured out, again, some places 10, 12 miles thick. In a little area underneath Lake Superior, it's all lava. This is near Lake Superior in Canada. And you can see they're stacked. They got tilted later, and they found a lot of copper in these lava flows. The little gas bubbles on these filled up with copper later as the rocks progressed along. Copper was injected in hydrothermally, and they mined a lot of copper in the Upper Peninsula of Michigan for many years in these lava flows. So let's go back to the Bible now. That's kind of the beginning of the flood. That might have gone on for 10 or 20 days for all we know. Just tremendous amounts of outpouring of water and lava all over these cracks all over the earth, and you can kind of see those. So let's go to chapters 1 to 3. Start looking at these sediments now. They start getting spread across the continents, starting with the Cambrian sediments. And it goes on and talks about the rain was on the earth 40 days and 40 nights. And I believe it talks about rain only because if you were a human, you weren't being flooded early on. If you were an animal, you really weren't being flooded. All the earth was flooded early was just shallow marine areas. So if you were a human observer, if you're inside the ark like Noah, and you're looking out the little window, you're just watching rain come down. The ark doesn't even float until after day 40, according to the biblical text. So there was a lot of rain, and then the flood really came in. And that's when, so the first 40 days, I think, are just 40 days of rain, intense rain all over the earth, probably because of these fountains going off. But that's speculation, obviously. The Sauk and Kaskaskia mega sequences, we're going to look at these. We kind of talked about the pre-Sauk as that lava that might have poured out of the mid-continent rift. But here, the Sauk typically and Kaskaskia, chapters 1 through 3, they're very, very similar in a lot of ways, but different. These big tsunami waves are starting to be generated. Now you start to move some of the plates. And John Baumgartner has shown that these plates would move very, very rapidly. He's used one of the most sophisticated computer programs in government research labs, and he's a world-renowned geophysicist, and he's shown that these plates are going to move very, very rapidly. Once you start to subduct, once the subduction process begins, it's going to run away. And it's going to move almost frictionless until it runs out of energy. And the energy was the old crust. The old original crust that God created was much more dense and cold. And once you ran out of that cold, dense crust, everything kind of stopped. But that's kind of when the flood ended, as we'll see. But the initial runaway will go meters per second, miles per hour. Today, plates move this much a year because they're not really driven anymore. There's no big difference in contrast in density. But he's actually shown the math would work that you get runaway subduction. Now you got to think back 100 years ago, nobody believed in plate movement. Geologists were like, there's no plate movement. But all the evidence was showing that there's continents matched up. Today, they won't admit that these move fast because that would go against their paradigm of an old Earth. But the science and the math that John Baumgartner used has never been refuted, it just gets ignored. So if you're correct, and it goes against mainstream science, they'll just ignore you. And unfortunately, he's ignored. But there really would be runaway subduction or catastrophic plate tectonics, and you get these huge tsunami waves like the one here in Japan, but even bigger than this. You gotta imagine tsunami waves 10 times bigger than this. We make the flood too small, just like we make God small, because we're finite humans. We can't imagine things bigger than what we see. But the flood was more intense. It totally changed the face of the earth in more ways than one. I think it almost melted the crust from below. Many of these metamorphic terrains that we see all over the world are actually caused by differential melting and heating from below. But again, that needs a lot more research. You need a lot more of you guys to go into geology and do some research in creation science. But this is the Sauk, the basal Sauk sandstone layer. So this whole yellow mass that comes from Michigan, my home state, all the way into Texas, all the way up through the Rockies, and all the way around up here in northernmost Canada, it's all one big sandstone. One sandstone layer. In many places, it's just a few feet thick. These are all my data points. You see those little dots on there? I'm not making this up. This is what the rocks show. It's one layer. You drill down here 15,000 feet or so, you'll hit it. There's a sandstone down there. It may only be a few feet thick, but there's a sandstone in almost all these locations. And you go to my home state of Michigan, the pictured rocks on your left side, same sandstone you see in the bottom of Grand Canyon. It's the Tapeats and the Grand Canyons, the Munising Formation in Michigan. So you go back and you see all that yellow, that's all one big blanket sand, which is difficult for the secular world to explain how you get one continuous sandstone layer that covers that much of a continent. Because they had to say it took millions of years for rivers to go working around from here to here to here to here to here, and just many places just leaving behind 20 feet of sand. The exact same sands all the way across. Very, very difficult. You can look through the literature and talk about blanket sands, it's still a mystery. But the flood explains it. And then you go to the Tippecanoe, the next sequence. This is the basal Tippecanoe with the St. Peter sandstone. It's a little smaller than we've been putting it. This is the St. Peter sandstone here in the middle of the country. Very, very pure. We make a lot of glass from the St. Peter sandstone. It's so pure. But look, it comes in Hudson Bay. There's wells up in Hudson Bay. So this blue is a little more limestone kind of coming in around the edges. Probably was a little deeper water. But this is just the bottommost rock type in that sequence. And then above that, you get shale and clay and everything else. In the Kaskaskia, you see a lot of limestone. All that blue is almost a blanket limestone, a Mississippian limestone. From my home state of Michigan, all the way down here to Texas, all the way up through the Rockies, all those big, thick limestones, the Mississippian limestones you see all over the world, they're also here, all the way across the United States. Again, one big, huge, continuous limestone. How do you get these big blanket sands and limestones unless there's a blanketing flood-type layer that spread this stuff across? And if you look at the fossils in the Sauk, the Tippecanoe, Kaskaskia are all the same. They're all pretty much marine critters. Shallow marine critters. There's almost no coal, no land plants, there's almost no land animals. So they say we evolved from marine critters. Well, what's really shown is what was buried first. Shallow marine areas were buried first. Shallow marine only, all over the world. Europe, North America, South America, Africa, it's all shallow marine. And I'll show you some maps of where these fall in. So if you go and look at these, what they look like in museums, these are the animals in the Sauk or the Cambrian, the Tippecanoe, shallow marine, Kaskaskia, shallow marine. You get a little different critters each time, but you're getting shallow marine critters only. So for the first 40 days, I believe, all you were flooding was shallow marine areas. Much of that was across North America. So this is the thickness map or isopac map if you're a geologist. This shows that 3 kilometers thick or more over here in the east, over 3 kilometers in the west, very thin down the middle, almost nothing. Right down the middle of the country. Almost nothing through here, 0 to nothing. White means nothing. It's 0. It's either eroded. Sometimes the waves came in and eroded as they came back. Yeah, but it left behind this much. So you've got less than, just a few hundred meters at most or none, 3 kilometers over here, over here. Well, John Baumgartner actually said that when you subduct things, this is kind of a cross-section profile from here, from Massachusetts, across Michigan, all the way to the west. You can see here's the Sauk, Tippecanoe, Kaskaskia. The red is the volcanics of the pre-flood, the pre-mid-continent rift and things like that. So there's all that thick stuff I showed you earlier. But here's the Sauk in green, and the darker green's the Tippecanoe, and the Kaskaskia is yellow. You see it's all pretty much over here, very little over here in the west until you drop off the edge of the continent. And this is what you see, it's sort of a sedimentary wedge from rapid east coast subduction. So you get this 3 kilometers of sediment because you're subducting the east coast, making the Appalachians ultimately. And John Baumgartner, in his model, showed that as you subduct rapidly, you're going to pull down the continental crust about 3 kilometers. And he predicted that before I went and found the 3 kilometers are actually there. To me, that's quite an amazing prediction. He predicted 3 kilometers of pull down, you get 3 kilometers or more of sediment. So you've got this wedge of sediment that builds up, which became the source of sediment for the Appalachians later. So let's move on to chapters 4 and 5. We only got 6 chapters, so hang in there. So this is days 40 to day 150 maybe, I don't know for sure. But the Bible tells us this, and the flood was 40 days upon the earth, and the waters increased and bare up the ark. So on day 40, it looks like that's when the ark started to float. I think that's when you started to flood the land. So land started to get flooded around day 40. We know that because the ark started to flood. We assume Noah built the ark on land, not on the water, obviously. And the waters prevailed and were increased greatly upon the earth, and the waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered. Again, it's hard not to see that this was a global flood when you read the words. All the high hills were under the whole heaven, not just the Middle East. All the high hills under the whole heaven were covered. But God's telling us in yellow, the waters increased, the waters prevailed, the waters increased greatly, the waters prevailed exceedingly. To me, it's quite clear. He says the water went higher yet, and then it still went higher. And he goes on to say at day 150, it went over the top. You flooded everything. Every air-breathing animal that walked the earth, every air-breathing human that walked the earth was dead by day 150. If you weren't on the ark, you were dead by day 150 of the flood. That's a long time. I think a lot of humans lived up to almost day 150. It must have been a terrible thing. Seeing the water getting closer and closer and closer, and you keep going higher and higher and higher. The water's getting closer and closer and closer, and the water's getting higher and higher and higher. 150 days is a long time. The first 40 days, you're like, it's just a lot of rain. And then they start to flood the land, you're going, this is bad. Let's move up higher. This is getting worse. Day 90, day 110, you're like, this is really bad. Dinosaurs are getting wiped out, and you're like, this is not good. I should have listened to Noah. How many people got on the ark? 8. And there might have been 1 billion people on the earth. Maybe more. In 1,600 years, you can get a lot of people. Only 8 people believed. Why hasn't Christ come back again? Because he's patient. God is patient. He's waiting for us to come. The ark, the door of the ark was salvation. All you do is walk through that door. Believe Noah. Believe there was going to be a flood. Believe what Noah was preaching about. God said there's going to be a flood. All you do is walk through that door. You were saved. He could have taken all of us, all y'all, onto that ark. There's plenty of room on the ark for hundreds of more people. But yet only 8 people walked through that door. Only 8 people believed. Today, Christ is the open door. He's the open door for salvation. He says, I'm the truth. I'm the door. You just enter through him. Believe in Christ and you're saved. So today, God is waiting patiently for more to come to him, more people to walk through that door and accept him as their Savior. He paid the price. Infinite God gives us infinite salvation, infinite forgiveness for our sins. I know I'm not worthy, but God paid the price. All you have to do is believe. All people had to do in the time of Noah was walk through that door, and they were saved. Today, we just have to accept Christ. It's very simple. But a lot of people just can't do it. The Absarica, moving right along, or some of you would say Absaroka. But I say Absarica because I went to school in Wyoming. They say the Absaricas. But this is the time where things got really bad. This is day 40 to day 150, starting in that range. And so this is when you start to flood the land. You start to get the first coal seams show up at this time. The ark starts to float, probably a little violently. And this is the basal sand in the Absarica. It's actually got a lot of mud mixed in there in the middle as well. But it's coming now mostly from the west, coming in this way. And there's less over here. And she's starting to form the Atlantic Ocean. Actually, that's salt showing up in here as you start to go down here in the Atlantic Ocean. But here you're coming in from the west. As you'll see, there's some limestone, some sand, some brown is the clay or the shale. Working in some volcanics showing up. You're starting to get subduction occurring on the west coast. So you get volcanics starting to show up. All these little pieces start to show up. This is the thickness map showing the isopack. Over 3 kilometers mixed out through here, basically from here to here. So Texas gets covered pretty much with about 3 kilometers of sediment here and there in different places. It's very thin up here. So now you're coming from a different direction because you're subducting differently. Instead of the east coast, you're now subducting the west coast. So now we have west coast subduction going on. This starts to build California and Washington and Oregon. So to smear on what's on the original ocean, moving it on out. And so you pull it down 3 kilometers over here, and you start to put 3 kilometers of sediment in. That's exactly what we saw, 3 kilometers of sediment being deposited in the southwest. So now you make a whole new ocean crust. Geologists will tell you that the oceans are young. They only go back to the Jurassic, which is about this point in the flood, about the very end of the Absarica. So the ocean's turned over completely starting from this point on till today. Completely new crust. The continents are older. Some of that goes back to creation week. But the oceans have been turned over like a conveyor belt completely during that runaway rapid subduction. So the youngest is in red. You can see the red areas are actually in the middle of the Atlantic, kind of East Pacific to the Indian Ocean. Again, whole new oceans formed during this process, but it all began right about here. So you get the splitting up of the continents ultimately. North America split from Europe, split from Africa. South America finally splits in the Cretaceous, moves away. And you get a shift in depositional pattern, which we talked about earlier. Early on, we had a very thin zone down the middle. It's thick here on the east, thick in the west. Now it's thick here mostly in the southwest. And it's very thin down the, and so you start to go up that area here systematically, flooding up that thin zone, which comes into play later. So the Absarica is the first appearance of large sand waves. You read through your books and they talk about these sand waves in Zion National Park and sand waves in the Coconino Sandstone. But we believe these are water waves, not sand waves. They're not from dry, arid environments. The Coconino Sandstone has been studied by my colleague John Whitmore, and they found dolomite ooids in the Coconino Sandstone. Dolomite ooids today only form in areas like the Bahamas where you got waves washing in and out, making little round balls of carbonate rock. How do you get dolomite ooids in a sand dune? Unless it's water deposited. And they publish this and people still ignore it because they stick with the story. Don't mess with the story. You know, these are not sand dunes deposited by wind. These are sand dunes deposited by water. And when you examine the science, it actually supports it. So huge sand dunes form all over the world. Starting about the Pennsylvania, the 10 Sleep sandstone in Wyoming. We used to look for that. We used to look for oil in the Bighorn Basin when I started with Chevron. 10 Sleep sandstone is supposed to be this aeolian environment. Well, it's deposited by water as well. And that's where they all begin. You see the first appearance of coal beds. The Pennsylvanian coals really kick into gear early in the Absarica because you're now flooding the land. You're ripping those trees apart, moving them inward and burying them rapidly in these coal seams. Coal seams have flat tops and bottoms because they're being transported. There's no roots that dig down underneath that you'd get in a swamp. You just get massive amounts of coal. Some of the coal seams later in the flood in Wyoming in places that are over 200 feet thick. And they're 60 miles by 60 miles. And they're stacked. That's where most of our coal comes from in our country, from the Powder River Basin. But that's a little bit later. The Zuni, this is, I believe, the high point of the flood. And it's the high point of the flood on all the continents, including Europe now, which I don't have any data to show you yet. But see these little dots up here? That's the bathtub ring. You know, you fill your bathtub up, what happens? If you're really dirty, like when I was a kid, you know, there'd be a dirty ring around there. You go to Hawaii, you see where the lava fills up, it burns the rocks around these craters, and you see when it goes back down, you can see the ring. Well, this is the ring because the water went over the top here. Now, most of this is crystal and rock today. So you're thinking, it didn't flood everything. Well, how did you get this here? And this here, and other places like this in the world? This is the Welsh show. Now, the Bible tells us, if you read through the Bible, the highest hills were covered by 15 cubits of water. And I believe Canada was one of the highest hills. And if you're only covering it with 15 feet of water, you can't leave a lot of sediment behind. You can't leave thousands of feet of sediment if you're only 22 feet deep. So the highest hills were stripped off real rapidly with tsunami-like waves so nobody could survive, right down to the crust. Everything that was there was stripped right off. But yet it didn't leave a lot behind, but it left enough. And some of these remnants, I think, are very, very telling to show that the water did go over the top. Because the secular world says, well, there's no sediment there. So they don't believe it flooded everything, but the evidence is there that it did. And here's a cross-section again showing the Zuni in brown, thick offshore, very thin here, but you get a lot of Zuni over here in the west. If you look at the fossils in the Absarica and Zuni, we see a completely different story. Now we see marine critters, mixed with land animals, dinosaurs and stuff, and plants and coal, things that live on land. Now show up, but they're mixed. This is from the Paleobiology database. Former colleague at ICR did this for me, plotted up all these phyla of animals. And he plotted up in blue are the marine animals that live in water. In the red are land animals that lived on land. And he plotted them up by number. This is actually a secular database. We didn't make this up. And it shows right about here, where the Absarica begins, Upper Carboniferous, you see a sudden appearance of land animals. But you see lots of marine critters still, and you get more and more and more and more as you go up, because the flood went higher and higher and higher, burying everything as it went. Some land animals ran. They got higher up, they lived higher up. But you'll see a progressive increase in land animals from that point on in the flood. So you see land animals mixed with marine and coal. You see land animals mixed with marine. You see sauropods, dinosaurs. You see, in Kansas, we see mosasaurs, all these swimming critters that got mixed in there. They didn't just live in separate areas. They're actually mixed in the same rock units. It's in the literature. So you might wonder, how did the dinosaurs survive the early flood? Some of you kids are wondering this, right? She's like, all she cares about dinosaurs. There's your T-Rex. They swam as long as they could. And eventually the water went higher and even buried the mighty T-Rex. How did the dinosaurs survive the early flood? Well, this is the Sauk-Tippecanoe-Kaskaskia thickness map I showed you earlier. You see how thin it is down the middle. Thick here, really thin down the middle. Well, I call that dinosaur peninsula, and you'll see because most of our dinosaurs straddle that. This is where you find our dinosaurs. They straddle that thin area. It's a thin area because it was dry land early in the flood. Some of my old Earth geology colleagues said, well, how come there's no dinosaurs in Grand Canyon? Because it was not on the land. It was offshore. You don't find dinosaurs in areas that was marine, shallow marine. So this is what I drew out based on the data. There's some slop in it, so I did the 500-meter line. In all this area where those dinosaurs are found kind of straddling this, I think they lived in what I call Dinosaur Peninsula in North America. And the area where my home stayed over here in Michigan, and all this area was a pre-flood shallow sea, maybe a few hundred feet thick, or a few hundred feet deep of water. And the west was the same way. Here's Grand Canyon is down here. It's not on the peninsula. There's no dinosaurs living in the water. So if this is somewhat correct and it's based on these data points, this is where we would find our dinosaurs. And as the waters came in from the Absarica, they came in this way first and buried the dinosaurs down here. The Permian reptiles are buried first, Pennsylvanian rocks, across the Permian Basin, and then you go up here to the Jurassic rocks, Jurassic dinosaurs, and you go further north, you get to Cretaceous dinosaurs. So God systematically flooded this peninsula this way, and you see a progression from Triassic dinosaurs, Jurassic dinosaurs, Cretaceous dinosaurs. It starts to make sense of the big picture of things. There's a lot of little details, but that's what the big picture really shows. So in my home state of Michigan, we find only marine critters. There's no dinosaurs in Michigan. Indiana, Ohio, it's all marine critters. You go to Colorado, you go to Utah, you find dinosaurs. You go up in what's Canada, you would have found the mammals. You would have found where the humans are probably living. Humans and dinosaurs probably lived in completely different areas. Same time, just different areas. Who wants to live with a T-Rex? You know, seriously, who would want to live with T-Rexes and velociraptors and all the stuff you see in the movies? But the movies are a little exaggeration. But this has all been stripped right off, right down to the crust, and these these animals have been buried on top of the dinosaurs as they were stripped off and moved and transported down. So you go to the Badlands today, we see a lot of mammals. You don't find dinosaurs with lions and tigers and bears. You find beavers, you find squirrels mixed in with the dinosaurs. You know, those other mammals that we're more familiar with, like cattle and horses, all lived at higher elevation. So I think Canada was where they lived in North America. And there's also a plant zonation. There's non-flowering plants mostly lived in the lowlands, the swampy areas. Like we talk about here, where the dinosaurs were eating these, living in the lowlands. That dinosaur peninsula was probably a lowland area, maybe just a few hundred feet or 1,000 feet above sea level at the most. Higher up, you would have different plants, more of the deciduous trees that we're more familiar with. And that's what repopulated the earth afterwards. The flowering plants were higher up. So even the plants are supposed to go through evolution. But it's not evolution at all. It's just the order of burial in the flood. Ecological zonation explains it all. And we see this on every continent. It's not just North America. So this is kind of a crude drawing. But early on, this is the first 40 days of the flood. You're burying just marine critters. And it goes up higher, you get the swampy areas, the non-flowering plants, the gymnosperms, the ferns. Then up here in the green, stripped off most of these shield areas, the Brazil and West African shield, in Canada, the Canadian shield, would have been where the mammals and the humans were living in. All these trees became the later coals that we see in the Powder River Basin, jammed up against the Bighorn Mountains. This is our pre-flood world map. We're actually working on the pre-flood world based on our data. So you can kind of look here, this is North America. Here's the high ground in green. The light green will be the high ground, probably where humans were living, and most of the mammals. The dark green will be where the dinosaurs were living, and most of the gymnosperms and swampy areas. And in blue would be shallow seas. Everything else is deep sea. We had to guesstimate over here, it's Antarctica, Australia. I haven't got those continents done yet, but I got Africa done, South America done, and I've got about 90% of Europe done now. And we keep seeing the same pattern. So we put it all back together in this sort of Pangea-like world, which John Baumgart and I agree on. We see this kind of thing. And this is actually based on data. I'm not just I made up some of it because we don't have this done yet. We had a guesstimate over here, but this area is based on data. And that's what we see. You plot up where the early rocks were, then where the later rocks were, and you can actually make thickness maps and you can plot these things up. But we'll probably never know the location of Garden of Eden until we get to heaven. You know, was it And what I'm seeing is one big landmass here, and maybe a smaller landmass here, because that gets stretched at the top. And then another smaller landmass over here, because that's stretched at the top. So this might have been where Adam and Eve were, but God might have put animals on all three of these little land masses if this is correct. Who knows? Interesting to think about. Moving on, the water did go down, just like the water went down here in Texas, right? You guys had a flood a while ago? It takes a while to go down. So the water went to its high point day 150, and then it took another, over 150 days to go down. God made a wind to pass over the earth. The waters assuaged, the King James says, means the count went back and forth. The fountains of the deep, the windows of heaven were stopped. The rain was restrained. The waters returned from off the earth continually. After the end of 150 days, the waters were abated. So the water rose for 150 days, and then the ark kind of hit ground, even though the water was still there over the earth. And we're going to have a globe in our Discovery Center Museum up in Dallas, opening up probably early this fall, that's going to show this. It's going to be the only globe of its kind, 48-inch Omni globe. It's going to show the progression of the flood based on our data that we're putting in. We can update it as we go along. But eventually the water went down, and even secular scientists believe the water went up and down based on the movements of the plates. More rapid plate movement pushes more water up from below because it makes more seafloor. If you have hot seafloor is like a hot air balloon, it rises, pushes the water up. So as you made more and more seafloor, particularly starting in the Jurassic, you pushed more water up higher, so the tsunami waves went higher, went higher, went higher. And so rapid seafloor movement and creation of new seafloor actually caused the flood to go over the top, push the water up. So you don't even need really any, you start out with the original oceans, just had to push the water up. Just like the bottom of your bathtub goes up, the water's going to spill. Bottom of the bathtub goes down when it cools. As you made the new crust, eventually it cooled and sank, pulled the water back off. And so the water was drained back into the oceans, and that's where they reside today. The Tejas thickness map is here. This is the receding phase of the flood. Notice most of it's around the coasts. And this is when the Rockies pop up. Actually, about 80%, not 80% of the world's mountains all form at this time. Ask your resident secular geologist, how come 80% of the world's mountains form at one time in geologic history? Even if you believe in millions of years, why do you have all your mountains form at the same time? This is that isostatic rebound from all that rapid plate movement, and then it kind of comes to a halt, and then you get over-thickened crust. Over-thickened crust causes the rocks to go higher in both directions. It's isostatic. So the Rockies rose rapidly, 5,000 feet, 10,000 feet. Basins formed rapidly, dumping these sediments, and you see tons and tons and tons of sediment piled over here in the American West. Here's the Cascades, they're eruptions, but look at this. This is where most of you guys in oil and gas work. You work the Gulf like I did. Well, why is all that there? Well, it's because it drained off the continent. And it drained off so rapidly that it pushed out sands as well into the deep water, which is a mystery. I got a story I'll tell you a little later. Here's the thickness of the Tejas, that yellow. It's really thick over here, but if you drove down to the Gulf, of course, we'd see a really, really thick zone. This is a secular diagram from a publication a couple years ago showing the Zuni. The early Cretaceous here, the drainage based on zircons, looks like it was drained to the north, and then there's a really rapid shift into the Paleogene, or the Paleocene, whatever you want to call it. There's different names for the same thing. Suddenly everything's draining down to the Gulf. So even the secular world recognizes there's a rapid shift in drainage. And they said that was from the Cretaceous interior seaway shifting directions. They believe it was from a flood, they just don't think it was the flood, but they recognize it was a flood. It shifted direction from drainage to the north. Suddenly everything is draining to the south. And it's not just one river, it's not just the Mississippi, it's the whole area. You can see here 4 rivers, big sheet wash draining into the Gulf. Well, if you have sheet wash going into the Gulf, you're going to get a lot of sediment. And this is the basal Tejas lithology, and this is the sandstone. All this is the sandstone at the base, dumped off into the Gulf. This is seismic data off Mexico, I projected out. But here's a lot of the sands shed from the Rockies popping up. All the tops of the Rockies shed their sediments real rapidly. And so you expose these cores of these mountains, and it was shed out, burying the mammals in the process. But in the Gulf, you shed all this material out there, and I have to update this map because it goes down to Mexican waters now too. But this is the Whopper sand. It's over 1,000 feet of sand in the deep water, 7,000 to 10,000 feet of water. About 10 years ago, they drilled into this and they found over 1,000 feet of sand, and then 1,500 feet of sand, 1,000 feet of sand or more. And when I was at Chevron, they told us, don't even look. This is 200 miles offshore and more. They said, don't even look 100 miles offshore, there's no sand. So we weren't supposed to look beyond 100 miles offshore. 2,000 feet of water, that's it. Don't even bother looking, it's all clay. 'Cause that's what rivers do today. Rivers dump their sand, and the clay goes out further out. Well, how do you explain the Whopper sand? There's really no good explanation for this. It's there, but the flood explains it is that, the initial pulse of changing the direction of water advancing, suddenly it turns around and goes back off. You're going to get a lot of energy, just like sheet wash off a parking lot. Then the water's going to diminish over and over. Eventually, you start throwing clay out there. So today, there's no clay, or there's no sand going that far out. But there's this huge Whopper sand. I presented this in Calgary at the AAPG meeting a couple years ago, and my old chief geologist from Chevron came by. He was 82 years old at the time. He goes, I want to see what you're doing, Tim, because they knew me. And I was an AAPG representative for a while, and so he came by, and he goes, I want to see what you're up to. I talked about the Whopper sand, and I said, Don, you guys wouldn't even let us look this far offshore, because you didn't think there was any sand out there. He goes, yeah, we were wrong. I was like, yes! All these years, I waited for him to say that. Our management never was wrong. They'll tell you that. You guys know what I'm talking about. Management is never wrong. If you're a manager in here, sometimes you're wrong. Keep that in mind. But they wouldn't even let us look out there. Fortunately, Shell and BP were drilling out there ahead of Chevron because we were slacking behind. We were afraid. There's nothing out there. They had their minds made up, secular uniformitarianism in their head. How do you get sand out there? Well, there's another one of these in the Jurassic. I wrote about that as well. The Norphlet goes all the way out there too. The Norphlet sand goes way out there. It's 1,000 foot thick too. And it's on top of salt. The Norphlet's supposed to be a wind-blown sand dune. How do you get it out in the deep Gulf on top of salt? So you have marine salt being deposited in the secular story. Then suddenly you have an exposed arid desert with nothing in between, just boom, boom. Where'd the water go? So there's lots of problems when you believe the secular story. People just don't point it out. When you go to school, they don't tell you about these problems. They just say, here, believe this, believe this, believe this. They don't tell you, well, we don't understand this. So anyway, the Whopper sand to me is a mystery, and to me it's justification that there was a draining of the floodwaters coming off North America. And you can see the fossils are marine and mostly mammals, but there's still marine fossils even in the Tejas. So you see lots of marine fossils. So I put them back together. This is the first flood sequence across 3 continents when you put them together into Pangea. This is the thickness maps. You see just a little bit of flooding early on in South America in the Sauk. A couple little remnants here and there, but you see a lot of coverage across North America, just a little bit across to Africa. This is where all the oil is in Africa. Well, why is it there? Because you stacked all the early rocks there. All the early shales are there with all the organic debris. All that marine algae got buried early on and became the source rocks. So this is one of the richest areas for oil because that's where the original sediments are being deposited during the flood. And that continued for the first 3 sequences. And so you go to Michigan, you can see the same sandstone as in Petra Jordan. It's the same sandstone. Across Michigan here, all this area, that yellow blanket sand continues across here, Petra Jordan included. So you don't have to go to Petra Jordan, just go to the Pictured Rocks in Michigan. It's a little shorter drive. It's about 1,400 miles from here, I think, 1,500 miles. Spend a night. This is the flood maximum. Here's those little points up here that I told you about the bath water. Look at Africa. What it was earlier was just a little bit. Now most of Africa is covered. This is crystalline rock, a lot of those other areas, just at the Canadian Shield. It's extensive amounts. And you can see that where the flood's receding. There's a receding phase. The Tejas in North America. Here's the Whopper sand out here, plus tens of thousands of feet of other sediment. Here's Africa. There's a Whopper sand out here. You guys just haven't drilled that far out yet. There's a Whopper sand out there. So if you guys are in oil and gas, get out there and drill 15,000 feet of water or so. There's a huge sandstone reservoir probably sitting right out here, just like there is over here. That's my only addition to oil and gas. There's another Whopper sand coming. You guys can find it. Be the first ones to get out there. Get out beyond the Niger Delta and get a little further out. There's probably a Whopper sand where it drained off. Here's the numbers, and you add up the numbers. Here's North America, And it's based on rock type. Again, yellow is sand, brown is shale, red is volcanics. There's some salt in there in pink. Blue is the limestones. Early on, you see, this is 10,000 cubic kilometers. So you're looking at, a few thousand cubic kilometers, a few thousand, spread over a large area. And not a whole lot, all of a sudden it goes up a little higher, then boom, it jumps way up. That's the high point of the flood, I think. You see more volcanics later, but the actual sediments peak here. See the same pattern in Africa, even more dramatic because there's no mountains getting in the way. You know, no Appalachians, no Rockies. It starts out minimal, boom, jumps way up and jumps way up. Africa not only covers all Africa, it covers it deep. Tremendous amounts of Jurassic and Cretaceous sediments, and then it comes down again. So you see the peak. And then South America, a little bit more, jumps way up, I think the high point of the flood. And then you get actually more Tejas because the Central America starts to form. So you have more sources of sediment that wasn't there early on. So here's South America, the progression of the flood. Here's the Sauk, a little bit, Tippecanoe, a little more, Kaskaskia, Absarica, Zuni, the high point of the flood. And here it's going down. The Andes pop up, boom, just like the Rockies. So in case you guys missed that, early flood, a little more. Now you're starting to get land animals and dinosaurs and coal. And then you finish off the dinosaurs, boom, high point. And then you get the receding phase of the flood, going mostly offshore in areas off Amazon. There may be a big whopper sand out here too. You guys got to get further out. See, when I was in the industry, we couldn't drill 10,000 feet of water. That's crazy talk. We couldn't see underneath the salt. You guys now go way out and you can see underneath the salt. I had Chevron buy a whole bunch of leases, sub-salt prospects, but they gave them all away because they couldn't see underneath them. They said, Clarey is an idiot. We're going to release them all. So they did. So now Chevron's been playing catch-up in the Gulf. They bought other companies because it's lower risk. So here's the pre-flood geography again I already talked about. So that's the global flood. The oil wells, the data, the columns show the same pattern on every continent. And the same thing is happening in Europe. Same pattern, same high point, same going down. It's a global event, just what God told us it was a global flood. But let's look a little bit about the evidence for it being catastrophic and not tranquil, because people argue it's a tranquil flood. It just kind of went up and then went down. Was your flood tranquil? Okay, yours was a local flood. God said there'd be no more global floods. So if your flood was a local flood and the biblical flood was a local flood, God's lying to you. Because there shouldn't be any more floods at all. But he said there wouldn't be another global flood, not other floods. And unfortunately, floods happen and people die and things get destroyed and ruined because of floods, but there's no more global floods. And we'll also see there's a recent flood. So let's look at what I used to dig dinosaurs in Wyoming. What do you find? You find bone beds. You find dinosaurs ripped apart. Very rarely do you find complete dinosaurs. You find these bone beds about this thick that might cover this room, or twice the size of this room, has thousands of bones in it from different species, all ripped apart. And you find more marine fossils in these beds than you do dinosaur bones. They just don't tell you about those. They're in the papers. They're in the articles, and you read about them. And there are some pictures of land plants in the Green River Formation with fish eating each other. They didn't choke and die. They got buried when they were eating each other. We have this in our ICR office. We have a dinosaur on top of a fish from China. And you see polystrate trees where these trees were deposition was so rapid the tree didn't have time to decay. So you see these ones, well, that's evidence that those sediments didn't take thousands of years to be deposited. Those sediments were deposited probably within days of each other, maybe even quicker. Immediate death positions, like I talked about over and over in the Green River Formation, other formations, you can find fish that just ate fish, preserved perfectly. No decay, nothing, buried instantly. Dinosaurs were buried rapidly. They weren't buried slow at all. This is from the dinosaur DVD series you can buy out there. It's kind of sad, but if you weren't on the ark on day 150, even as a human, you were dead. 150 days of judgment. To me, it's nothing to laugh about in that case. It must have been very sobering for those humans that didn't get on the ark. And we see dinosaurs. My favorite dinosaur of all is this one. Here's a velociraptor, which is really about this big. Kids, velociraptor is really this big. Skull's about that long. The movies don't tell you the truth. I just wanted to let you guys know that. This is Protoceratops. Oops, I went too far. Protoceratops was about to bite down on us. See, it's got its little mouth right in there about to bite down like a trapped rat. It's fighting back. All it could do was bite hard. And so it's about to bite down, and the waves just came in and buried instantly. It's like two WWE wrestlers going at it in the ring and just buried instantly. Headlock position. Flying drop kick. They're buried instantly. Secular science says, well, this is a sand wave collapse, sand dune collapse. But to me, this is the tsunami waves coming in, just burying stuff. A wall of sediment and mud came in and just buried them instantly. That's what you see. You see mummified dinosaurs with the skin imprint still on them. You see flat planar deposits. You go to Colorado, Wyoming, you see it goes on and on and on in all directions. You see millions of years of erosion. I think recently this has been downgraded to only a few 100,000 years. But, you got the cochineal sandstone on top of a hermit shale, which is very soft in red. Even if it's 900,000 years or 700,000 years, where's the erosion? You've exposed this rock layer for 700,000 years or maybe millions of years. Why aren't there some gullies? Everything erodes. They don't talk about this when I took geology class either. They're just stacked on there. 160 million years of time missing between the red wall and the Muav limestone below it. It's perfectly flat. Maybe a little bump once in a while, but almost perfectly flat. How do you explain that if there's time there missing? And you see the sequence boundaries, the mega sequence boundaries are often flat as well. There's some erosion, of course, near the mountains, but most times they're just flat on top of flat on top of flat, just brick upon brick upon brick, just like the way you build a brick wall. Brick wall doesn't tell you how much time between this brick and that brick. But you all know it couldn't have been too much time or the bricks would have fallen over. There would have been some erosion. But we don't see that. We see bone beds, we see instant burial, lack of erosion between the sequences. The only reason they tell you there's time there is because they use radioactive dating, which we'll talk about in our next talk. So they fabricate time, but the evidence in the geology is not there. So it's catastrophic, it was global, and it was recent. So let's go back to the bones. So I'm not just making this up. I'm not just going, well, the Bible says this, so I'm going to believe it. It's true, but it's backed by science. And since 2005, and actually go back before 2005, they actually found dinosaur original proteins, dinosaur DNA snippets, dinosaur blood vessels, dinosaur what appears to be red blood cells. Red blood cells in dinosaurs have the nucleus still, unlike ours, and that's what they see. They see osteocyte cells. And we'll see what Mary Schweitzer has to say here when she discovered this in 2005, and her advisor is Jack Horner, when she talks about Jack. I actually dug dinosaurs with Jack Horner back in 2000. I just didn't say anything. I was digging away and having a good time. But I asked one of his PhD students, I said, how do you explain dinosaurs are supposed to be like birds when they have completely different hip structure? They walk completely differently. He's like, it's not a big deal. I'm like, okay. So I didn't say any more, but they found all these original proteins. Physical chemists, if any physical chemists in here, have shown for years that collagen, one of the most durable proteins, makes up your skin. Most of you are Texans. You have cowboy boots on, you rode horses, right? You have saddles. Saddles and cowboy boots are made out of collagen. You leave that around for a few years, what happens to them? They don't last forever. Even in the best conditions, they can get them to only last about 900,000 years. They project out. They can't even last 1 million years. And yet, we're told that these things are 68 million years old. They've even found soft original tissues in worms that are supposed to be 500 million years old. 500 million years old, and yet they're still soft original proteins. How can that be? So we'll see what Mary Schweitzer had to say back in 2006. But you can argue we have so little. I'll do that in the next talk. We have so little dinosaur soft tissue. Here's those red blood cells I was telling you about. See that little nucleuses in them? Nuclei? Nucleuses? I make up words like George W. used to do. Nucleuses. Our red blood cells don't have nucleus. They lose them, so you have a little dent there. But the reptiles do. And these are the blood vessels, and the osteocyte cells we'll see later as well. But imagine you have enough organic tissue to fill a barrel, 42-gallon barrel, millions of barrels. Well, we have billions of barrels of soft tissue. Oil is another soft tissue. It shouldn't be there. When I worked for Chevron, they told me the oil in Wyoming is from the Jurassic, 150 million year old oil. Migrate in there and just sitting there waiting for us to find. 150 million years old. just sitting there. We drill into it, and there it is. It works. It must be 150. They do basin mod and all these things, and you can model it out. But they set the ages as millions of years. But when you study these things, oil doesn't last that long. We spilled all the oil. BP spilled all the oil, and unfortunately, people died in the BP explosion. But what happened to that oil? Most of it biodegraded. Bacteria loves oil. There's bacteria in the ground. There's bacteria as far as we've drilled, there's bacteria. There was a paper a few months ago that came out saying 3 miles down, there's still bacteria. Yellowstone National Park, there's hydrophilic bacteria, almost to the point of boiling. That's where all those colors are. If you go to Yellowstone, you'll see there's really, really hot bacteria. Bacteria eats oil. And most of the oil we produce is biodegraded to some degree. I think all the oil we produce is only 1,000 years old at the oldest. When I look through the literature, how do scientists explain old oil? As they have to go with this idea that it was pasteurized somehow magically. They don't use the word magically, but they actually say it was pasteurized at 80 degrees Celsius. Because I studied hydrogeology for my PhD, I saw that there's fluids constantly moving. Constant groundwater flow everywhere. Fluid flow is constantly moving, bringing new bacteria in. So I don't care if you pasteurized it for a while. Once that stuff gets near the surface, it's going to get eaten up. There's bacteria everywhere, as far as we've drilled. And the bacteria is not as fast underground, or we wouldn't have any oil. But oil was from the flood. Oil was produced by marine algae buried in the flood. We can make oil in an hour in the government research labs out of algae. A lot of you know that. If it wasn't for the flood burying that oil, burying that marine bacteria or marine algae rapidly, it would have all decayed away before it was actually buried. Like today, it's going to the bottom and it decomposes. But if you bury it rapidly, it'll preserve it. So God, even in his providence, provided oil resources for us today in the flood. He provided coal for us today, knowing that we would need these energy resources. Coal and oil is not the enemy. Some liberals think it is, but coal and oil is actually there for us to use. We could burn it cleaner, we could spill less, but I think coal is a wonderful resource. You wouldn't want to waste it. But oil reserves over time, of course, thanks to the fracking, that's what this jumped up here. Everything jumped up, especially in North America. See that big kick? We were running out of oil. Remember, we're all going to die, we're running out of oil. Boom, all of a sudden we doubled our oil reserves overnight. Oil, again, global energy consumption. This is the fossil fuels provide 86% of the energy. This is from 2014. How are you going to get rid of fossil fuels in 10 years, like some politicians are saying, when it provides all of our energy for the world? And it's pretty clean energy, actually, especially natural gas. I agree we need to diversify a little more. You can't rely on one source all the time, but until we come up with something better, this stuff's working. There's plenty of it. And unfortunately, geologists ride the wave. We get laid off, and every time we find too much, it's the only profession I know, you're too good at your job, you lose your job. It's like, you're laid off, we don't need you anymore. I'm like, come on. It's not right, is it? If you're a good surgeon, do you lose your job? Good geologist, you lose your job. And about 40%, I read, 40% of the oil we produce is used to make plastic. So how are these millennials going to have cell phones and computers when they get rid of oil? Noah didn't have oil. He didn't have oil. Oil, that was a different Hebrew word altogether called kofir, which means a covering. Oil really doesn't appear in the Bible until you get to Tower of Babel, when they used pitch for mortar. Just oil seeps in the Middle East start coming out, we'll see as we go along. Oil and gas, 56% in 2014. So here's the little fracking diagram. You go down thousands of feet, you frack, hydrofrack. We were fracking when I was in the business, but it was vertical. But now they go down horizontal well drilling, they frack, and these fractures don't make it up here to the surface to, ruin people's water supplies. Like they're telling you, they don't go that far, but you need regulations or people overdo it. Here's the fracking oil in yellow, how much more we've increased. Texas has got a lot, North Dakota's got a lot, but you can see in Texas, the big jump was in the Permian Basin, the Midland Basin, Midland area, West Texas, and actually the biggest oil fields are here in West Texas. Biggest oil field in the country now. Eagle Ford in East Texas, Prudhoe Bay, Alaska. Look, Alaska's nothing. Most of you Texans don't even admit Alaska's a state, right? Texas, big, everything's bigger in Texas. Well, you got the biggest oil fields. Texas is nothing, Alaska's nothing by comparison. Then you got the Delaware Basin, the East Texas Basin, those are Texas too. So you get, 4 of the top 6? You guys are kicking butt. Go Texas, but yet unfortunately you find too much, it drops the oil and everybody gets laid off. So it's kind of, here's, anywhere you drill here practically, you get oil. But, back in the day you couldn't go, they're going to the source rocks. If these source rocks really produced their oil millions of years ago, why is there still oil there? Ask yourself, if we frack a well, and the oil is supposed to be produced 100 million years ago, 50 million years ago, why is there still oil? Why didn't it migrate away? Nobody understands migration very well, but there's groundwater movement all the time. That's how the oil moves. It moves with the water. It moves a little slower than the water because it's a bigger molecule, but it moves with the water. Bacteria moves in the water. It's all moving around. One of the problems with age dating things, the radioisotopes, is they're also being flushed with water constantly for millions or billions of years if they want to believe in that. So how do you know what's originally there and what's not? The oil's being flushed as well. You got to, this is the classic picture out of a book, How to Find Oil. It looks like it's really easy. And it is. It's kind of fun. I kind of miss it. Found some oil. I missed as well. I drilled a really dry hole in Texas, but that's another story. Because there was no reservoir rock. Anyway, it's not really from dinosaurs either. That's just a story we tell you. It's mostly from marine algae. But you can look at these Devonian shales. You've got these huge Devonian shales across the eastern U.S. that they're fracking now. It's one big shale, just like that big sandstone we talked about. How do you get shale that goes that far? And it's a mystery to these guys. And they say this, the Devonian, Mississippi, and Chattanooga shale and equivalent that cover much of North America, well, the eastern U.S., and whose widespread extent is poorly explained. So they really can't explain in the stratigraphy books how you get these big shales that cover this vast area, nor those sandstones that are even bigger. Conventional thought is this. I don't know why there's a big A there. Kind of worries me. Shales, clays form under environmental conditions in which fine sediment is abundant and water energy is sufficiently low to allow settling of suspended. We've all seen this. You take a bunch of clay and water, mix it up and set it down, it'll slowly settle out, right? That's how they tell us all shales form. Well, that's not true. And they're finding the last 10 years is completely different than that. It's the fable of slow deposition. Clay actually deposits, they tell you it took as thick as that dime there, might have taken 1,000 years. But that's a fable. Oil must be buried rapidly like all fossils, the marine algae, just like these things, which I threw in there earlier. The real answer to clay deposition is being found in Indiana University's Flume Lab. The last 10 years or so. There's been a lot of studies, and I actually went to Indiana University's field course. Spent 2 days in there, but they're finding that laminated shales like we see, when you look around the rock record, clays are always laminated, shales are always laminated, really fine, thin layers. To get those layers, you got to have persistent currents. Persistent currents. It's not slowly settling out. And it has to be energetic depositional. History has to be water moving. The flood provided water moving to make these laminated shales. All over the world we see laminated shales. And here's the truth is clay is deposited rapidly. To mimic these laminations, you got to have water moving, what's the figure, 1 foot per second. Now it's not really fast, but it has to be fairly fast. It's not just slowly settling out. So just by saying, well, how do you get 5,000 feet of shale? It doesn't mean it took 5 million years. They can actually deposit these much more rapidly than they're saying. There shouldn't be laminated shales because they all should be bioturbated. Today you go out there in the deep ocean, you take a core, you rarely see good lines because they get all bioturbated with critters. So if you had real slow deposition, you're going to get these layers are going to be destroyed. Bioturbation can destroy primary sedimentary structures such as lamination and create in their place a variety of traces, blah, blah, blah. Basically to mix it all up. Like a potato masher. You're not going to see fine laminated clays, but yet we see these. Oil generation, kerogen's a solid disseminated organic mass. Again, you got to crack it. It's got to get in the oil window. You got to bury these things deep under 1,000 feet of sediment, and the Earth's natural heat kind of cracks the oil out of it, produces the liquid oil known as cracking in the oil window. 5 to 10,000, 15,000 feet down. Here's the oil window being generated. If you have the right kerogen, you got to bury it deep enough to get oil. So there's a lot of basins, like the Hudson Bay Basin is not deep enough to generate oil. Canadians drilled some wells in there. They found some Cretaceous sediment, but it didn't produce any oil because it didn't go deep enough to get in the oil window. So you got to have your organic rich shale has got to be buried deep enough. And so here again, in 60 minutes or less, our government research lab took marine algae and under the right conditions made it into oil. But it takes more energy to make that than to find it. But we can make oil from marine algae. What does the Bible say? Oil was generated quickly, I think, in about 200 years after the flood. They said in Genesis 11:3, it says, "Then they said to one another, 'Come, let us make bricks and bake them thoroughly.' They had brick for stone, they had asphalt for mortar." This asphalt was the oil seeps coming up in the Middle East after the flood. So the Tower of Babel is maybe 100, 200 years after the flood, because we don't know, it's in Peleg's lifetime, but there's about a 200-year window. So within about 200 years, I think you had real oil coming up. And here's the oil seeps today in bright green in the Middle East. So here we are where the Tower of Babel was built presumably somewhere in Iraq. All these light green areas are oil seeps even still today. Underneath the Gulf, there's oil seeps coming up. Underneath California, there's oil seeps coming up. If we don't find this oil, it's just going to keep seeping up anyway. So we might as well use it. Find it and use it. Here's an oil seep in the Middle East right here. So they found this oil was useful to help with the bricks, with the mortar for the bricks. So the truth of oil formation is oil forms quickly under the right conditions. Within a few hundred years after the flood, you're already getting oil, according to the Bible. And there's no reason to doubt the Bible, because we can make it rapidly in the laboratories in 60 minutes. So the earth can generate it quick enough. We just need the oil to get from deep down to migrate up to the surface, that's all. Oil is a naturally occurring organic compound made up of carbon, hydrogen, and what's called a hydrocarbon. It's an organic compound. This is some of the compounds in oil. It's always that benzene ring. Carbon and carbon and carbon. These are soft tissues. Oil is proof that the oil is not that old. So when you're pumping gas, filling your tank up, you're really putting in 150 million year old oil in your brand new Lexus. You're not. You're putting in oil that may only be a few hundred years old. It can't be that old, or it would have biodegraded completely. The tar sands are examples of oils biodegraded much more thoroughly. But it's organic. It can't be that old. Oil is organic tissue. We have billions of barrels of proof that the flood was recent. It wasn't a flood that happened, millions of years ago. It wasn't 6 series of floods that happened over tens of millions of years. It was very, very quickly. But man's philosophy, of course, we talked about this earlier, there should come the last days scoffers. A literal reading of the Bible, here's David Montgomery, when he wrote his book, The Rocks Don't Lie, in 2012. But the answer to that is people do. The rocks don't lie, but the people do. And so here he is. He says, a literal reading of the Bible requires that such sedimentary rocks already exist at the time of the flood because bitumen, the pitch or tar Noah used to caulk the ark, comes from sedimentary rock. So that's his argument. But what does the Bible really say? They're willingly ignorant. Pitch, if you go back to that Hebrew word, it's actually kopher, K-O-P-H-E-R, kopher. Doesn't have anything to do with oil, which is the word used later. It's really just something that covers. It's a sheath or a covering. So we don't know what the material was, hence the difficulty in translation. The other 16 times that kopher is used in the Old Testament, it is not translated as pitch. So unfortunately, they translated this one as pitch, and they shouldn't have, but yet people argue then that we had oil before the flood. But there was no oil before the flood. The oil was caused by burial of marine algae in the flood, so it wasn't oil until after the flood, like at the Tower of Babel. This is not pitch. It does not mean, in this case, put the original Hebrew word in there, it doesn't mean oil at all. So the truth of the pre-flood pitch is oil was not used in the ark. Pitch was not a hydrocarbon. It might have been a tree resin or something they cooked up, who knows, but it wasn't oil like we know oil. So bottom line is this, a worldwide mountain covering deluge would have deposited most of the world's oil-bearing rocks rapidly. And if some of you wonder, well, is there enough oil out there? Is there enough biomass to explain all the oil we found and are going to find? And this was done in 1978 by a secular scientist. The volume of the biomass in the ocean sediments today, has got so many grams of carbon, 2 times 10 to the 22nd, just a few percent of what has ever been found in terms of oil. So if you buried everything in one day, what's alive out there in the ocean today, and buried it all, it would only amount to just a small percentage of what's been found. Now, you might argue since 78 we've doubled or tripled our oil reserves. Well, then it's maybe 10%. But you're still nowhere near what could be buried in one day, let alone a year of the flood or 150 days of flood waters. So hopefully tonight this long, boring talk has confirmed a couple of things for you, at least made you think about things, that there was a global flood, the rocks really do support it. All the continents I've studied show it, same pattern up, same pattern down. It was catastrophic. We see the evidence in the fossils, it was catastrophic. And we see the evidence in the rocks themselves of all these original tissues and proteins that can't be explained. I argued with the old Earth geologist the last few months. He's like, well, it don't mean anything. I'm like, what do you mean it doesn't mean anything? This is empirical data. Original tissues are empirical data. This is as close to proof as you can get in geology. You know, you're always looking at a forensic science. You can't go back in time. But this is as strong a proof and as empirical as you can get. Yet they just try to dismiss it and say, well, we just don't understand how they're preserved. I'm like, maybe they're not that old. Maybe the age is all a lie you guys have been spreading for 150 years now, ever since the time of Hutton. Well, for those of you who are little kids and barely going to make it through, we are talking about dinosaurs next, but we're going to take a little short break and have time for a little answers. Q&A. Big Plans for Henry. There's a book that my wife and I wrote about a dinosaur that gets on the ark, because my wife's 15 years, she was a teacher at kindergarten, and she says there's nothing out there that you can read a story to that talks about a young Earth. She had to cross out all these at a Christian school, she had to cross out all these millions of years. Well, this is a little story about Henry, who gets chosen by God to be one of the representatives of the duck-billed dinosaurs on the ark. And you can tell the girl dinosaurs with little eyelashes from the boy dinosaurs. And so there's something you didn't know before. Anyway, a shortened version of this talk is available for $10 out there, The Truth of the Genesis Flood, without all the oil in it. But it talks about the rocks and the sequences. And I have a book coming out on this summer that covers the first 3 continents. And it does talk about oil and coal and the plate tectonics and all these things. And there's introductory chapters on all that to kind of catch you up on it. It's written for about the high school level. That should be out in the summer. And then I did write a dinosaur book. The last couple of chapters of this show that dinosaur peninsula. They show how dinosaurs fit in the rock record in North America. And I think it's in, Jason Lyle, who used to work for us, says this is the best dinosaur book he knows on the market. Ken Ham sells it in their Ark. I'm in the Ark, yes. And, a lot of people sell this book. It's a pretty good book. It's got a lot of good pictures. If you don't like the reading, the pictures are wonderful. And if you don't want to read, you can watch the DVDs. So this is a little more expensive. This is where those video clips came from. They all came from this 4-part DVD series on uncovering the truth of the dinosaurs. But each one of these is 22 minutes. This cost us close to $1 million to produce. It's done by a professional studio in Dallas. And we got some really good people in there. Unfortunately, I'm in there a few times, but there's other people in there. So it's not so bad. But it's actually pretty well done. It talks about soft tissues as well. And so if you want to know about that. And then if you don't buy anything tonight, this is the best book of all. Because I didn't write any of it. They wrote it at ICI just before I showed up 5 years ago or so. And this covers a little bit of everything. It covers the gap theory, it covers the day-age theory, and it covers the human genome, how we're only about 80% like chimps. When you look at the whole genome, we're nowhere near 98%. That's a big lie. But it's in all your textbooks. It's never going to come out because they like it. But we're really only about 80% or less like a chimp. So chimps and humans are not really that much alike after all when you look at the whole genome, which my colleague Jeff Tompkins did, who used to run the genome lab at Clemson University for many years. Brought in millions of dollars in grant money, but he left to come work for ICR. And Jason Lyle wrote a lot of astronomy stuff, et cetera, et cetera. There's stuff on dinosaurs in here as well. With that, I'll stop. I think we have a little bit of time for a couple of questions, then I'm going to get started again in about 10 minutes on the next talk, so I don't keep you here all night. We have more questions at the end if I don't get to them all. Yes, sir?
So the rain, you think that the rain only came from evaporation, none of that?
Well, I don't believe there was this big, huge canopy like we used to think, because they did the math. You do the math, you test ideas, and it didn't show that there was 40 days enough of rain to come down from some sort of a canopy. So whether there was a canopy up there or not, it doesn't explain to me the rainfall for 40 days. And so that's another matter. Yes?
Do we have an idea what the elevation was for the ark?
That's a good question. What's the elevation for the ark? I'm not sure. I think the highest hills might have been maybe 5,000 feet. I got to go back and do some math and see how thick the rocks are and do a little more thinking about that. I don't know, but I don't think it was that high. The whole world, the highest hills might have been 5,000 feet high. The ark might have been only like 1,000 feet high. So once the water got up to that level, it started to float. So I think the ark was built on the edge, pretty close to where the pre-flood water was. Maybe not that high, maybe just a few hundred feet. We're going to start again at 8. I can answer more questions at the end until I'm blue in the face. But we'll have to cut off the questions now, get a little break.